Let's look at internal and external forces and how they affect the motion of an object in a system. Here are our learning objectives. Understand the difference between an internal force and an external force for a system. Be able to identify internal forces, external forces that balance, and external forces that do not balance for a system. We need to apply Newton's second law to systems of objects. There's some pages. Here's our table of contents, and let's get to our preview. System is a collection of objects that are connected, literally or figuratively, in some way. An internal force is a force where both the object and the agent are parts of the system. An external force is a force where the object is part of the system, but the agent is not part of the system. Fundamental particle is a subatomic particle that cannot be divided down into parts. All right, let's get to it with systems. Treating many objects like they're one object. A system is a set of objects. These objects are connected either literally or figuratively. If it's literally connected, there is a physical connection between the objects. The cars of a train are literally, physically connected and can be considered a system called the train. Figuratively connected is when the two objects have some interaction or relationship, even if they are not physically connected together. For instance, the solar system consists of many objects that are not tied together, but interact through gravity and can be called a system. Everything is a system. We've got the human body, made of individual parts called the organs. An organ is a system made of individual parts called tissues. Tissue is a system made of individual parts called cells. Cell is a system made of individual parts called organelles. An organelle is a system made of individual parts called molecules. A molecule is a system made of individual parts called atoms. Atoms are a system made of individual parts called protons, neutrons, and electrons. Protons and neutrons are made of particles called quarks. Quarks are made of string, maybe. Electrons and quarks cannot be divided any further, so they're called fundamental particles. Knowing that protons and neutrons are made of quarks is not important for AP Physics. At least this one. If you take AP Physics 2, then yes, at least at the time of this recording, that may change. So we will say that the fundamental particles are proton, neutron, and electron. We will not deal with these particles until later on. But they're always there. We can always look at how protons interact with electrons because we know enough about physics to do that already. So what is an object and what is a system? In physics, when can we say that the human body is an object? And when can we say that it is a system? If the situation we're considering does not involve what goes on inside the human body, then we would treat the body as just one object. For example, if we're analyzing a person running a 100-meter dash, right? We don't care about what's happening to the cells or the tissues inside of that person. We're only looking at, let's say, the time that it takes them to travel 100 meters. So we only care about the whole thing as just one. If the situation we're considering requires looking at the inside of the human body, then we're going to treat the body as a system consisting of some objects. For example, if we're looking at the pressure exerted by the heart on the bloodstream while the person runs a 100-meter dash, then we have different things happening. So we would treat the heart as one object. Meanwhile, we have the veins as another object. So there's multiple objects within the human body for that instance. Another example, if a car comes to a sudden stop, what are we looking at? If the driver is secured in the car, so the driver and the car have the same motion, we can consider the driver and the car as a system and treat them as if they are a single object. If the driver flies through the windshield, they're no longer connected. Then the driver and the car must be treated as separate objects, not as a system. Newton's first law example there, right? Point is, as long as two or more objects have the same motion, we can consider them a system and treat them as a single object. If a force acts on an object in a system, then that force also acts on the system as a whole. Each force acts on a system can be classified as either an internal force, which the object that the force acts on and the agent exerting the force are both parts of the system being considered. Watch this a couple of times. I know it gets confusing. Object, system. Seems like I'm saying it over and over again. It's a very particular way to word this. So objects, systems, agents, all of this stuff is very particular. An external force, the object that the force acts on, is part of the system, but the agent exerting the force is not part of the system being considered. Let's go back to the driver in the car. Here are some forces that may act while the car suddenly stops. We have the road exerting a frictional force backward on the tire. The seat belt exerts a tension force backward on the driver. The driver exerts an applied force forward on the brake. The road exerts a normal force upward on the tire. The car seat exerts a normal force upward on the person. The earth exerts a downward force. Earth exerts a downward weight force on the car, person. Driver exerts a forward applied force to the steering wheel. Which forces are internal and external to the system, and which are external to the driver-car system? I'm going to read that again because I don't think I read it properly. Which forces are internal to the driver-car system, and which are external to the driver-car system? Driver-car. Right. So in blue, we're looking at the internal forces, the driver and the car. So if it deals with inside of the car, literally, the driver or the car. Driver exerts an applied force. If it's external, then it's in red. The road, the earth, those kind of things that are not part of the driver-car system. So things that are outside of the system acting on are the external forces. Things that are within that system are the internal forces. The big one. Uh-oh.
Mr. Ruthie,